Good morning, afternoon, evening, ladies, gents, wherever you are. This is another review video for my grade 9 science class in Ontario, but feel free to watch it wherever you are, whoever you are, I don't care. These are drawing Bohr Rutherford diagrams. We're going to do a review of other terminology that came from yesterday's video, which is periodic table basics. As always, it's Mr. Benjamin here. Big smiley face. Learning goals for this lesson. First thing we're going to do is review key terms. So, proton, electron, neutron, these are all subatomic particles. Particles. I forget how to spell sometimes. These are what make up our elements. Valence shell electrons. Ooh, we'll talk about those. We also have to keep those in mind for bonding and reactivity. Nucleus. That consists of our neutrons and our protons. We've also got atomic mass and atomic notation, which go hand in hand. We're going to keep in mind, or we're going to review, how to calculate atomic mass, knowing that it consists of both protons and neutrons. And finally, we're going to actually draw our Bohr Rutherford diagrams. So, reviewing key terms. Subatomic particles. These are the things that make up elements. TS. There are 3 subatomic particles, the first of which is a proton. Keep that in red. Positive charge. Weighs 1 atomic mass unit, and I'll write AMU for that. There's neutrons, which are neutral. The first 5 letters are the same. Okay, so always keep that charge in mind. A lot of people say it's negative, and that's incorrect. These have a neutral charge, but also weigh 1 AMU. The ditto marks mean the same as directly above. Then we have electrons, which have a negative charge. And weigh nothing. They don't actually weigh nothing, but for our purposes, they weigh nothing. Valence shell. This is the outermost shell. That holds electrons. And it is involved. That's a weird looking E. In reactivity. So we talked about halogens and alkali metals in the previous video. Those are the groups on the periodic table, and those groups are more reactive due to their valence shell electrons. This group of numbers here, 2, 8, 8, 18, 18, this is the order for valence shells electrons. And that'll make sense once we start drawing them. 2 is the first, that's how many electrons go with, then 8, then 8, then 18, and 18. And that's based off the periodic table, and I can show an image of that afterwards. One thing I forgot to mention, protons and neutrons are both found in the nucleus. And again, that's important when we start drawing our Bohr Rutherford diagrams. So atomic mass and atomic notation. Atomic mass. This is made up of protons and neutrons. So for example, if I take, chlorine's always my favorite example, has an atomic mass of 35. The atomic number, which is the same as protons, is 17. I believe it's 17, yeah. Therefore, if AMU is equal to protons plus neutrons, and we know atomic mass is 35, and protons was, what do we say, it was 17. So we should be able to find out what this value of n is. If we do a little rearranging, be 35 subtract 17 is equal to 18. Therefore, chlorine has 17 neutrons. Atomic notation for chlorine would look something like this. Cl 35, oh, that's a weird 3. 35, 17. So let me see if I can move that guy over there. That looks okay. So that's the atomic notation for chlorine. So now the actual drawing of the BR diagrams. I'm going to always start with atomic notation. Let's erase that and draw it underneath. Okay, so for oxygen, we know the symbol for oxygen is an O. By looking at our periodic table, oxygen we know has a mass of 16, an atomic number of 8. And we know that this is protons, and this is atomic mass. So if we do 16 subtract 8, we would get 8. Therefore, we have 8 neutrons. The one subatomic particle we're missing is electrons. We assume elements are electronically, I'm going to rewrite that. Electronically balanced. Therefore, positive charges, and I'm going to write that in red, must equal negative charges. So we know oxygen has 8 protons, so 8 must equal 8. So that would be 8 electrons. Okay? So I'm going to list off for oxygen protons, neutrons, electrons. Actually, it's 8, 8, 8. So that information is needed for our Bohr-Rutherford diagram. I'm going to erase this part here because I need the space. Please forgive me. Okay. In the middle of every element, or of every atom, is our nucleus. Okay? And the nucleus consists of, let me erase that a bit better, protons and neutrons. And we know we have 8 and 8 in oxygen. Now, the one thing we're missing is electrons. Electrons are actually floating around in clouds. Okay? These clouds are called shells. The pattern, or the number that each shell can hold, coincides with the pattern of 2, 8, 8, 18. This is from the PT table, or the periodic table. Okay, and that's just the rows across on the periodic table. So our first shell can hold 2 electrons. Oxygen, we've said, has 8 electrons. So if we subtract 2 electrons, we still have 6 to go. We have to put 6 more on here. Our second shell can hold 8 electrons. So we're going to draw them equal distance apart for the first 4, then we're going to start pairing them up. So 2, 4, 5, 6, 7, 8. Get rid of those circles because we don't need them. But that is our Bohr-Rutherford diagram for oxygen. It looks a little messy, looks a little complicated. Let's do another example. Carbon. Carbon's always fun to do. There's a specific reason for it. So let's start off with the atomic notation. Symbol of C. Mass is 12. Atomic number is 6. This is the same as the number of protons. So if I list out P, N, E, we have 8 protons. We have an atomic mass of 12. 12 subtract 8. Oops. We don't have 8, we have 6. I don't know why I said 8 there. Please forgive me. 12 subtract 6 is 6, so that equals our neutrons. And electrons, we know, are the same as protons. So that's also going to be 6. We'll get rid of this stuff. Oh, I erased my P. Oh man, I gotta draw that again. There it is. So we know this is 6 as well, and 666, well, that's not good, but that's okay. In the middle, start off with our nucleus. In our nucleus, we have protons and neutrons. 6 and 6. Around our nucleus go our shells. Remember the pattern, 2, 8, 8, 18. First shell can hold 2. 1, 2. We have 6 electrons in total, and we just used 2, so we have 4 left. So we need to fill 1, 2, 3, 4. And that is it. That's the Bohr-Rutherford diagram. I don't know what that says. I'm going to write it again. Diagram for carbon. Right there. Cool. Chlorine, my next example. 35 atomic mass, 17 atomic number. It's the same as P. This subtract 17 is equal to 18. So, protons, neutrons, electrons. Protons, we said we had 17. Neutrons, we calculated mathematically, it's 18. Don't want that dash there. And electrons is the same as protons, so that's going to be 17. In the middle, we have our nucleus. Protons were 17. Neutrons were 18. First shell, remember the shells. Go 2, 8, 8, 18. First shell can hold 2 electrons. So we've used 2, we have 15 left. Second shell in total can hold 8, so we're going to draw all 8. 1, 2, 3, 4, 5, 6, 7, 8. The electrons like to be paired up in 2s, which is why they're like that, but they also have to be equal distance apart because they're all negative. Negativity, stay away from each other. So we just used 8. We have 7 left. We have to fill 7 more, so we need a third shell. 1, 2, 3, 4, 5, 6, 7. So in total, 2, 4, 6, 8, 10, 12, 14, 16, 17. We're good for electrons. Our nucleus is good. So that's it for chlorine. In some cases, you don't just have elements. You have compounds. For example, H2O, which is water. We've already done oxygen. Oxygen's right here. I'm going to draw it again really quickly. Oops. Let's start off with, I'll do it right here. Protons and neutrons is 8 and 8. We have 1, 2. I'll draw the rest in blue. 1, 2, 3, 4, 5, 6. So I actually don't need this shell. Hydrogen. Hydrogen's much smaller. It's actually the first element. So let's write out our P, N, and E. Has 1 proton, actually has 0 neutrons, and 1 electron. If I look at my oxygen, I can see that these 2 pairs are already doubled up, or those 2 electrons are already in pairs. I have 2 single electrons here. If I draw hydrogen as a Bohr-Rutherford diagram, it has 1 proton, and then 1 electron. So basically what happens is these 2 electrons become very close friends. And we're going to have another hydrogen right here. That's water. That's what water looks like as a Bohr-Rutherford diagram. We are into our 14th minute here, so it's a good time to end this video with a highlighter thank you and a happy face. Hope everyone's staying healthy. We're all going to get through this eventually. Have your faith, stay strong, have a great day.